When analyzing data, we often need to examine descriptive statistics such as standard deviation, standard error, or the coefficient of variation. These are typically summarized in a short table, but in some cases, it may be necessary to include such statistics directly in the original dataset for further analysis. Let's upload a dataset to begin. I would like to calculate the mean, variance, standard deviation, standard error, 95% confidence interval, coefficient of variation, and the 25th percentile of yield data, grouped by genotype and treatment. I will use the following R code to perform these calculations. However, I would like to append these descriptive statistics to my raw dataset in order to include them in my figures. To facilitate this process, I created a new R package called descriptivestat. Below is the basic structure of the code. I will calculate the mean, standard deviation, coefficient of variation, interquartile range, and other descriptive statistics, and append them to the original dataset. This package inserts the mean values between data rows by group, and the corresponding descriptive statistics are also added to the raw dataset. I'll create a figure. If you would like to use standard deviation as the error bar, you can simply modify the code accordingly. This dataset enables visualization of both the raw data points and their means, along with standard deviation, standard error, or other descriptive statistics. Here is another example using a large dataset. This is a large dataset used to measure wheat grain area in response to a thinning treatment applied in the field. In each plot, alternate wheat rows were removed to increase assimilate availability by reducing competition. Due to the large number of data points, visualizing individual raw data is not practical. Instead, box plots or bar graphs would be more appropriate. However, I would like to visualize both the raw data and its variability. In this case, the descriptive stat package is useful for that purpose. First, I will output the standard deviation and interquartile range known as IQR for this dataset. This graph will help illustrate both individual variability and the overall trend in the data. Since the descriptive stat package appends the mean and other descriptive statistics to the raw dataset, we can easily use them for visualization. If you want to use upper and lower percentiles as error bars, you can simply modify the code as shown below. When compared to a box plot, the upper and lower percentiles are exactly the same as those represented by the box boundaries. Which type of graph do you prefer? While a box plot effectively summarizes data variability using quartiles, the graph generated with the descriptive stat package provides a clearer visualization by displaying the actual raw data alongside the mean and other descriptive statistics. For more details, please visit agronomyforfuture.com.